Good morning. In the last lecture, we discussed regarding to a best first search. In this lecture, we will discuss a greedy A star search or a star search. So A star search is basically going to be used for finding out shortest distance. So A star search has a little modification in its heuristic function. So A star search, as we know, it is an informed search strategy. It uses a heuristic value, and that heuristic value will be generated by one of the function that is called as a heuristic function. So A star search heuristic function is like this: f of n is equal to g of n plus h of n, where g of n is a distance of any particular node from its initial node and h of n is a distance of any particular node from its goal node, that is nothing but areal distance or a straight line distance. So as shown in the diagram, it is one of the map provided which is nothing but a map of different cities, and interested to find out the shortest distance from an initial node, that is nothing but the particular city from which we are interested to start, and we are interested to reach to a particular city, that is nothing but m as given in this map. So we are interested to reach from A to M along with the shortest distance by traveling a shortest distance. So we are taking into consideration this problem, and we are going to solve this problem by using a star search. So A star search required two values, that is nothing but a g of n, and second one is nothing but a h of n, where g of n is given in the map, that is nothing but, suppose we are interested to get a distance from its initial node, distance of any node from its initial node, then it is given in the map. That is, suppose we are interested to find out a distance of a node B from its initial node, then that is 75. Distance of a node J from its initial node, then it is 140 plus 80. From where it is going to be explored. So we'll take into consideration this particular map and we'll follow a star search. So we are starting from the initial node. As per our rest of the searching strategies, we are starting from the initial node, that is nothing but the initial city, that is A, and we'll check whether this is a goal node. If this is a goal node, then print succeed and stop there. We are using algorithm, and we are using a same type of algorithm where you are using a open queue. Here for A star search, we are using a queue data structure, or you can use also a stack data structure, but I am purposefully using a queue data structure, and I'm using a two queues. One is a open queue and one is a closed queue, and I'm going to utilize one of the variable x as per our usual method, which is equalized to a goal node. So our goal node is nothing but m, that is nothing but a goal state. So I'm going to start from an initial node, that is nothing but A. I'm going to check whether it is having a successor or it is a particular goal node. If it is a goal node, then print succeed and stop there. If it is not a goal node, then I am going to check whether it is having successors, and successors are nothing but a particular cities where it is leading from that particular node. So I am exploring as given in this particular map. So I'm checking a node A, and if it is not a goal node, then I'm going to check whether it is having successors. So A is having a successors where it is leading, that is nothing but D, C and B. Now I have to calculate a particular heuristic value by using a heuristic function f of n plus f of n is equal to g of n plus h of n, where g of n is nothing but a distance of node D from its initial node, that is nothing but 118, and h of n is nothing but a areal distance of node D from its goal node. So it is given to us. Okay, in this particular problem, they will provide us a particular straight line distances. So they are giving a straight line distance of node D from its goal node, that is nothing but 329. So I'm going to add that particular distance, and I'm getting a particular value 447. Similarly, I'm getting for C, that is nothing but a distance of node C from its initial node, that is nothing but 140, plus I'm going to add its straight line distance, that is nothing but 253 straight line distance provided to us. So I'm going to take that particular value, and I'm going to achieve a particular heuristic value on each of the particular node that I explored. Now I'll add them into a particular queue as shown in this particular manner. Okay, so I'll add them into a particular queue, that is nothing but open queue, and now I'll sort whatever element present in the queue such that a best element according to my heuristic function will come at the front end of my queue. So now C is coming as the best element according to my heuristic value, or we can say a promising element. So I'll now cross check first element C and I'll check whether it is a goal node. If it is a goal node, then it's okay, print succeed and stop there. If it is not a goal node, then now I'm going to check whether C is having successors. Yes, C is having successors. So similarly, I'll explore C. I'll check to how many cities it is leading. Okay, so as shown in the map, it is leading towards a particular cities, that is C to E, E to L and C to J. So I'm getting these particular nodes, that is E, L and J. Similarly, I'll calculate such heuristic value. For calculating a heuristic value of E, I'll take into consideration G of n. G of n will be calculated for a particular node E as 140 plus 151. So I'm getting 291 plus I'll be having a straight line distance of node E that is given to us in this particular problem, that is nothing but 380. So as I'll add G of n plus H of n, I'll get 671. In the similar way, I'll calculate for this node L, that is nothing but G of n is nothing but a distance of A to C, that is nothing but 140 plus C to L, that is nothing but 99. So I'm getting a straight line, and that G of n is equal to 239. Plus I'll add a straight line distance of node L, that is nothing but 176. So I'm getting 415. Similarly, I'll calculate for J. Then I'll add them to a particular queue and I'll sort whatever element present in the queue so that the promising element will come at the front end of my queue. Now J is coming at the front end of my queue because it is having a shortest distance, that is nothing but 413. So I'm cross checking J. Once J will be over, that is nothing but if J is not a goal node, then I'll check whether it is having successors. Yes, J is having successors, that is nothing but I and K. I'll check these successors. I'll find out its heuristic value. In the similar manner, I'll calculate f of n is equal to G of n plus H of n, that is nothing but distance of this particular node from its initial node. So I'll check distance this plus C to J and J to I. I'll add it so that I'll get a particular node, the particular value, that is nothing but G of n, plus I'll add H of n for this particular node I, that is nothing but which is provided to us. So I'm getting a value 520. Similarly, I'll calculate for this. I'm getting here 417. So I'm adding these two nodes into a queue and I'm sorting a total queue element so that the promising node will come at the front end of my queue. So now I'm getting a element L. I'll cross check that element L across X. If it is a goal node, then print succeed and stop there. As L is not a goal node, so now I'll check whether L is having successor S. Now L is, I'm getting a successor, that is nothing but M. So I'll calculate its heuristic value, that is nothing but f of n. So I'm getting a particular value, that is nothing but 450. In a similar manner, G of n plus H of n. G of n will be calculated as like this: A to C, C to L and L to M distance, which is given in the map, plus H of n, which is a value given to us, that is nothing but for M it is 0. So I'm getting a distance, I'm getting a value, that is f of n, that is nothing but 450. So I'm adding it to a queue and I'm sorting whatever element present in the queue. Now I'm getting a front end element, that is nothing but element K, which is more promising and which is having a value, that is nothing but 417. So now I'm cross checking of K across a goal node. If it is a goal node, print succeed and stop there. But here also K is not a goal node, so I'm cross checking whether K is having successor. No, K is not having successor. So I'll check the next promising element which is present in the queue after this K, which is nothing but D, with a heuristic value, that is nothing but 447. So I'll cross check a node D, and if D is a goal node, I'll print succeed. But D is also not a goal node, so I'll cross check whether it is having successor, but it is not having a successor. So I'll next check the next front end element of my queue. Now I'm getting a particular node, that is nothing but B. So I'll cross check a node B across my goal node, but B is also not a goal node, so I'll check whether B is having successor, but B is also not having successor. So I'll check the next front end element of my stack, which is coming after a B. So I'm getting a particular element that is nothing but M. So now I'll cross check M. So as I'm cross checking M, I'm getting M is a goal node. So I'll print succeed and I'll stop there and my goal node is achieved. In this way, a particular A star search algorithm is working.